Hello guys, welcome back to another video. In this video specifically, we're talking about the grouping method. One thing about this grouping, it works when your A value is 1 and also when your A value is greater than 1. So there are some real benefits to this method. You also need to know this all together for kind of like the second semester of Algebra 2. Now, when looking at these, I actually got all of these questions from Delta Math. So guess what? You probably will have a Delta Math assignment over this. So it's nice to see this. Factoring 2x squared plus 11x plus 5. And again, I'm going to use the grouping method. So first step is multiply your A times your C. We'll do this up here, A times C. And if you forgot, standard form is ax squared plus bx plus c. So my A is the first term, which is 2. C is my third term, which is 5. And I feel confident on doing that. That's just 10. So 2 times 5 is just 10. That was part 1. Step 2, find the factors that multiply to be 10. Well, we know that 1 and 10 work, and 2 and 5 work. And that's it. 10 is a pretty nice number, isn't it? Sweet. Next part, we're going to find two numbers such that when you multiply them, you get 10, but when you add them, you get 11. So how to get 10? 10 is your A times your C term. And how to get 11? 11 is your B term. All right. So in this case, my B term is going to be 11. And my A times C was just 10. So thankfully, we only have two pairs here to check. Well, 1 times 10 is 10. And obviously 2 times 5 is 10 as well. So let's check the second condition. If I was to add 2 plus 5, that would be 7. But if I was to add 1 plus 10, that would be 11. So with this here, 1 plus 10 ends up giving us 11. And also 1 times 10 gets us 10. So once we found that magic pair that works for us, and I'll rewrite the equation right here, 2x squared plus 11x plus 5. Okay, next step, and this is one of the more confusing parts, so feel free to replay this part of the video. I am going to break up the middle term as two separate terms. So, laser pointer. The 2x squared and the 5, those are literally just brought down. They stay the same. But this middle term, this 11x, I broke it up as a 1x plus a 10x. Where did I get those numbers from? I got it from this over here. This is why it was important that we find this second condition, because this second condition allows us to break up this 11x. Mathematically, I'm not doing anything bad or illegal. If I just gave you this part alone, just gave you that equation or gave you that expression, and I'm like, hey, combine like terms, you would have combined the x and the 10x because, well, they both have the same term and you're adding. So here, that's all I did. I broke up that 11x to say x and 10x. Now, with this next part, nothing too crazy here. I'm just going to now break up, my bad. I'm going to worry about the first two terms and then worry about the last two terms, okay? So within those first two terms, I want to take out my greatest common factor. So greatest common factor, again, just break apart that word. So factor, numbers that kind of multiply to be to each other. Common, a common number, so something they both have in common. And the greatest, the biggest number they both have in common. So for 10, the factors were 1 and 10 and 2 and 5. In this case, we're looking at the greatest common factor for 2 and 1. So greatest common factor 2 and 1, I mean, it's just be 1, so nothing too crazy there. But can I also take out an x? So this has an x squared and this has an x. So that means here, my greatest common factor would be x. They both have an x involved, so that means I can take out an x. And they don't have a biggest number I can take out, only a 1. So when I say take out, that is equivalent to dividing by that greatest common factor. So 2x squared divided by x, that's going to end up becoming 2x. And then x divided by x, it would be just 1. Remember, anything divided by itself is just 1. Well, except for, I guess, 0 divided by 0. That's something else. Okay, cool. So I factored out an x from that first part in the green parentheses. Now let me worry about that purple set of parentheses. So purple. Cool. So greatest common factor between 10 and 5, a number that goes into both 5 and 10 would be 5. A number that goes into both 5 and 10 would be 5. Can I also take out an x from there? Well, does the 10x and the 5, do they both have x's in common? They don't actually. That 5 does not have an x. So essentially, if I am factoring out a 5, I could say I'm like dividing by that number. So 10x divided by 5 would be just 2x, and 5 divided by 5 would be just 1. Again, these last two steps always trip people up. So if you need to rewatch that part of the video, totally fine. Final part here. What I'm technically doing is I'm still factoring out a greatest common factor. That just tends to confuse people when I say that, though. So look inside your parentheses. What do you notice? These are actually the same. The stuff inside of parentheses is the same. So let me write the common stuff inside the parentheses. And then in another set of parentheses, I'm going to write everything that's left over. So after I take out the 2x plus 1, I got an x left over. And after I take out the 2x plus 1, I got a 5 left over. And we're good. Now, I'm not going to do, so I want to show you why this works as well. Actually, I probably should put it right here. I'm going to go ahead and multiply these out just to show you why it's correct. I'm not going to do this for all the other questions just because it will make the video last a lot longer than it needs to. But for this right here, doesn't really matter what kind of method of distribution you use. Maybe you use box method, FOIL, or just distribution altogether. You're still doing the same thing. So here, I'm going to multiply each term by the other term. 2x times x, let me get a different color. 2x times x is 2x squared. 2x times 5 is 10x. 1 times x is just x, and then 1 times 5 would be 5. Combine my middle two terms. This essentially kind of like the reasoning why factoring works. Wow, can I not? Perfect. There we go. This is why kind of factoring works in the first place. So this is my expression I started with, right? And then from there, I broke it up as two separate terms, which, by the way, these are the exact same, isn't it? And then from here, I got to these two binomials. So you're essentially what you're doing with factoring, you're kind of just breaking it down to two binomials. And then with the proof per se, you're just going in the opposite direction. So these are both synonymous. But you don't need to know the proof for every single question because that would be a lot of work. Now, it's nice to know because it's nice to test yourself and nice to prove that your answer is correct. But this is by the method called grouping. Now, next question, 3x squared plus 10x plus 8. I want to do grouping. So first step, multiply a times c. Given an equation in standard form, or expression in standard form. I see that A is going to be 3 and C is going to be 8. So here 3 times 8 is just going to be 24. Nothing too crazy there. Now let's find the factors of 24. So two numbers that multiply to be 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Now we got all these factors of 24. We need to find two numbers such that when you multiply, two numbers when you multiply, you get 24. And two numbers that you add, you get 10. And again, 10 is my B term. 10 is my B term. So we got 4 pairs. We need to mess with those 4 pairs and see which one works best for us. So with this here, two numbers when you add them or subtract to get you 24. I'm sorry, they get you 12. Let's go through them one by one. Well, obviously 1 plus 24 is 25. That's clearly not 10. 2 plus 12 is 14, but 12 minus 2 is 10. Okay, so there's a possibility there. That might work. 3 plus 8 is 11. 8 minus 3 is 5. That won't work. And 4 plus 6 is 10. Okay, so we're stuck with two of them. 12 minus 2 is 10, but 4 plus 6 is 10 as well. So both of these have the possibility of meeting this second requirement. Let's check the first one. If we were to have 4 times 6, that would be 24, and 4 plus 6 would be 10. So it looks like 4 and 6 has to be our answer. If I was to say a positive 12 and a negative 2, while yes, those add up to be 10, if I was to multiply 12 times negative 2, that would be negative 24, not positive 24. But fret not, we have our pair 4 and 6, some of the best numbers to exist. That is not true. I just made that up. So 3x squared plus 10x plus 8. Now with this, again, I was looking for two numbers that were adding up to be my B term. And the reason why I needed that, because I'm going to utilize those two numbers now. I'm going to break up that 10x, and I'm going to say 6x plus 4x. Again, I broke up this 10x as two separate terms. And mathematically, I'm still fine. I haven't done anything illegal yet because 6x plus 4x is 10x. So I'm still having my expressions, they're equal to each other. So I'm still good, I'm still fine. This is why it's important that we find two numbers that add up to be our B term. Okay, next part is you are to worry about the first two terms and then the last two terms. So 3x squared plus 6x, let's find our greatest common factor. Again, our GCF is going to be a number that goes into both 3 and 6. So 1 goes in both 3 and 6, and 3 goes in both 3 and 6. So those are common factors. Then the greatest common factor would be 3 in this case. So it looks like we could take out a 3 from this first part and then ask yourself, okay, I could take out 3. Can I also take out an x? Do they both have an x in common? Oh, they do. The 3x squared and a 6x. And so that means I can also take out an x. So that's nice. And when I say I'm taking out an x, I'm essentially dividing by those values as well. So hopefully this brings out great memories from Algebra 1. 3x squared divided by 3x. So divide your coefficients and then go with your variables to variables. So 3 divided by 3 is just 1. X squared divided by x, it would be just an exponent of x. All right, 6x divided by 3x. Well, 6 divided by 3 is just 2. And x divided by x would be, just 1. So it looks like for this first set, those first two terms, the green parentheses, we're good. If you don't if you're still kind of stuck and want to make sure you got it right, you can make sure that you're still equal. Notice if you wanted to, you could distribute this 3x back to these terms. And you should still get this part here. 3x times x is 3x squared. 3x times 2 is 6x. So that means we're also good. Just a little way to check yourself. You don't have to, but it's nice to have that little assurance. 4x and 8, I need to take out my greatest common factor. So numbers that go into 4 and I go into 8, 1 goes into 4 and 8, 2 goes into 4 and 8, 4 goes into 4 and 8. So the greatest of those three numbers would be 4. Okay, ask yourself, can I also take out an x from my set of purple parentheses? I can't. Nope. The 4x has an x with it, but my 8 doesn't. Shame, shame. But it's totally fine because I could just divide by that greatest common factor. So 4x divided by 4. Okay? 4 divided by 4 is just 1. And I got x left up top, so we have just x. 8 divided by 4 is just 2. That's nice. Which is really good as well for grouping. Because if you get to this step and the terms inside the parentheses are not the same, that means, whoa, take a step back, backtrack a little bit and see where you messed up. So final step here is write the terms that are common, that are the same inside the parentheses, and then bring down everything that is left over. And I'll highlight that just so you can see. Again, x plus 2 because that was here. Let's do this color. And then 3x and a 4 became its own parentheses. Now, I'm not going to prove this by foiling. Oh, that's pretty. I'm not going to prove this by foiling or by distributing just to save time. But we would get our same expression, 3x squared plus 10x plus 8. Perfect. I think you got like 2 more in this video. 2x squared plus 13x plus 20. First step with grouping is to multiply that a times your c. And if you're watching this video, go ahead and pause the video and try this one by yourself. Again, this video is to help you get comfortable with grouping. That's why. 2 times 20 is 40, and from there we get two numbers that multiplied to be 40. You can use your calculator. I'll just use my head for this. I'm a nerd. Sometimes that math degree comes in handy. Sometimes, not all the time. 2 times 20 is that. 4 times 10. 5 times 8. And that would be it. 6 doesn't go into 40, 7 doesn't, and we'll start repeating. So between those four pairs, we want to find a pair such that when you multiply them, you get 40. And then when you add them, you get 13. Again, where are we getting 13 from? That is my b term, x squared plus bx plus c. So two numbers that multiply by 40, okay, well, they all multiply by 40, so that's nothing too crazy there. 13 though. So between those four pairs, we need to find a number. Let me orange. Perfect. Well, 1 plus 40 is 41. 40 minus 1 is 39. That won't work. Yikes, my bad. 2 plus 2 is 22. 2 minus 2 will be 18. 4 plus 10 is 14. 5 plus 8 is 13. Okay. Looks like 5 and 8 work for us because 5 plus 8 is 13. And 5 times 8 is 40. Why is this so important? Well, in our expression, 2x squared plus 13x plus 20, I can rewrite my middle term to be 8x plus 5x plus 20. Again, I'm rewriting that 13x by splitting it up to be two separate terms. Now, a couple things about this. You don't have to put the 8x first and then the 5x. You can say 5x and then 8x. Really doesn't matter. I'm just doing it just because I kind of see it's going to be a little bit easier for us. Again, it doesn't really matter which one goes first. But the purpose of that is we're going to take out some greatest common factors. So first two terms, last two terms, let's get it. So between the first two terms, 2x squared and 8x, I need to see what number goes into both 2 and 8. We got 1. We got 2 as well. 2 goes into 2 and 2 goes into 8. So it looks like 2 is the biggest number. Do they both have an x in common? Oh, they do actually. The first term, this 2x squared has an x squared, and the 8 has an x. So that means I can take out an x. And when I'm saying I'm taking out or I'm factoring out a number, I can say I'm dividing by that greatest common factor. Which is nice because 2x squared divided by 2x isn't too bad. Break it apart. 2 divided by 2 is just 1. And then x squared divided by x would be just x. Okay? 8x divided by 2x. All right, so 8 divided by 2 is just 4. And x divided by x is just 1. Again, to check yourself, you can multiply or distribute that 2x to everything inside the green parentheses. So you can do 2x times x, which is 2x squared, and then 2x times 4, which is 8x. So we're good here. Perfect. Purple parentheses. That's a hard word to say. 5 and 20, a number that goes into both 5 and 20. We got 1. We got 5 as well. Ooh, that's a big number. Ask yourself, between 5x and between 20, can I also take out a variable? So does that mean, do they both have a variable in common? They do not. That means I can only take out a 5, which is fine, and it's okay because that means I divide by 5. So here I'll do 5x divided by 5, which is just x, and 20 divided by 5, which is just 4. With this here, hey, the stuff inside my parentheses is the same. So that means what I'm going to do here is rewrite my stuff in my parentheses and bring down everything that is remaining. Again, I'll highlight this part just so you see what's happening here. X plus 4. And then we'll do this color. 2x and 5 became their own set of parentheses. And if I wanted to, I could multiply those two binomials together, and that would stay the same. With this last example, for some reason there's ink on this page. We're still doing grouping because you selected a grouping video. That's why. A times C is going to be 5 times 12, which is just 60. And again, feel free to use a calculator for this part. I'll just do it in my head. Hopefully I can. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, and that should be it. It is good. Wow, we got 6 pairs here. Nice. Well, within these 6 pairs, what are we looking for again? We're looking for two numbers such that when you multiply them, you get 60, and two numbers when you add them get you 23. But where are we getting that 23 from? Again, ax squared plus bx plus c. That means my a value is 5, b is 23, and c is 12. All right, so we got some tests to do real quick. We got 6 pairs, so let's go through them real quick. I'm about to talk really quickly. Ready? 1 plus 60, 61. 60 minus 1 is 59. That doesn't work. 2 plus 30 is 32. 2 minus 30 is negative 28. That won't work. Ooh, 3 plus 20 is 23. That might work. Let's check the rest of them. 4 plus 15 is 19. That won't work. 5 plus 12 is 17. That won't work. And 6 plus 10 is 16. So that means 3 plus 20, if you didn't see that already, would work in this case. Why? Because 3 plus 20 is 23, and 3 times 20 is 60. So the reason why that's important, because with my expression 5x squared plus 23x plus 12, I can now rewrite that middle term. Oh, my bad. Let me keep them black. I can now rewrite that middle term as a 20x plus a 3x. Again, with this here, I'm keeping the 5x squared and the 12 the same. I'm only splitting up this 23x to be a 20x and a 3x. So from there, this is nice. This isn't too crazy because I can worry about the first two terms, and then I'm going to worry about the last two terms. So with this here, again, a number that goes into both 5 and 20. We got 1 and 5. We got 1 and 5. So 5 is the bigger of the numbers. And then can I also take out an x? I can, because the first term is an x squared and the second term has an x. So that means here when I divide by 5x, I'm going to end up getting an x plus a 4. Again, you can test yourself by distributing that 5x back in the parentheses. Sweet. Go to purple parentheses now. Still a hard word to say. We're going to find out my greatest common factor. Well, 3 and 12, my GCF there is going to be 3. How do I know it's 3? Because 1 goes into 3 and 12, and 3 goes into 3 and 12. And 3 is the bigger of the two numbers. Can I also take out an x? No, because the 12 does not have an x with it. That's bad. That now means I'm going to divide by 3 in both of these terms. So 3x divided by 3 is just x, and 12 divided by 3 is just 4. And that is great news, because if we got to this part and we did all this and our parentheses were not the same, that means we should probably take a step back, kind of evaluate what's happening here. Okay, so with this here, 5x and x plus 4 and 3x plus 4, we're going to write down the common parentheses and then bring down everything remaining. As I highlight this just to emphasize it, this is by grouping. Now, grouping will work when your a value is 1, but I prefer for you to do the other method when a is 1, just because it's a lot easier and quicker. If you watch this whole video and you're like, I still don't like that, well, there's 2 other methods that you can do as well. If you have any questions, please let me know, and I'll be more than happy to help you. If not, have a great rest of your day.